Okay, this is part 3 of the Geometry Common Core Regents. We're going to be taking care of 32, 33, and 34 from this video, and then we'll move on to part 4 in the next video. All right, so for this one, it says, as shown in the diagram below, a ship is heading directly towards a lighthouse whose beacon is 125 feet above sea level. So here's our beacon. He's 125 feet. And here's our ship moving towards the beacon. He's just moving in this direction, right? At first sighting, at point A, the angle of elevation from the ship to the light was 7 degrees. So over here, where we started, when we just start looking over here, it's a 7-degree angle of elevation going all the way up. As he moves forward, right, a short time later, at point D, the angle of elevation was 16 degrees. So at this point, it's 16 degrees. To the nearest foot, determine state how far the ship has traveled from point A to point D. So we're actually looking for this distance. All right? Now, I'll show you the strategy to doing this one. Once you figure the strategy out here, it becomes a much easier problem. And what you should see is this. There's actually 2 right triangles here. You got a big right triangle, ABC, and you have a small right triangle, DBC. All right? And look what happens if I outline these. Okay, so I have DBC right here, right? So I got my smaller triangle. And then I have my bigger triangle, and I have ABC here. And what we could do is this. If I could find out what AC is, this whole length, and I subtract that from DC, which I can also find. If I subtract those 2 lengths, then I'm left with the length that I'm looking for, AD. All right? So let me show you what I'm talking about here. We're going to separate these 2 triangles. It's going to make this a little easier to do. So I got my big triangle and I have my smaller triangle. All right? Our big triangle is ABC. Our smaller triangle is DBC. We know we have 7 degrees here. That looks like a 70, so let's just do 7 degrees. And we know that the beacon's 125, and we know this is 16 degrees, and this is 125. Now, since we're looking for AC and DC, that's where our X's go. And you might remember, if we're doing trig, the 2 steps we do is label our sides, then write SOHCAHTOA. So first, we got our opposite here. We do not have the hypotenuse, and this makes X the adjacent. Same thing over here. This is our opposite side. We do not have the hypotenuse, and this is our adjacent. So now we write SOHCAHTOA out to ourselves, just to remind ourselves, which trig function are we using here? And this one, O over A, is tangent. So now we just got to set it up. We have the tan of 7 degrees is equal to 125 over X. In this case, we have the tan of 16 degrees is 125 over X. Drop some 1s under these guys, and we'll do a little cross multiplication. So bang, bang, we got 125 is equal to X times the tan of 7. And bang, bang, we get 125 is equal to X times the tan of 16. Now you might remember here, when you have X and tan on the same side, we're going to have to divide both sides by tan 7 to get to the other side. So we're going to divide here. We're going to divide both sides by tan 7. All right, and I'll write the answer there in a second. And we're going to do the same thing over here. Divide both sides by tan 16. Okay, so we do 125 divided by the tan of 7. I'm putting this in the calculator. You get 1018.04. I'll stop my decimals there. I recommend writing them all out, as always. All right, just round the final answer. Now we do the same thing, 125 divided by the tan of 16, and you get 435.926. 435.93. I'll just round that there, okay? Okay, so now that we got the 2 distances, we know this. We know that A to C is 1018.04, and we know that from D to C we have 435.93. And what we'll just do is subtract those and find our missing length of AD. All right, so let's move this down like so and just do a little subtraction. I'm going to subtract these 2 numbers. So putting this in your calculator, let's see, 1018.04 minus 435.93. You get 582 feet, 0.11, but this says to the nearest foot. So feet, The ship has traveled. Sweet, guys. Dope. All right, let's move on to our next problem. It's one of our favorites. Triangle ABC has vertices A at x3, B at -3, -1, and C at -1, 4. Determine state the value of x that would make triangle ABC a right triangle. Justify why ABC is a right triangle. All right, we should remember how to do this. Let's just move down a little bit. All right, I got to see the whole question here. All right, so let's plot the points we know. We know B is at -3, -1, so that's our B. We know C is at -1, -4, that's our C. And we know X is at X, and then the Y equals 3. So we're actually going to put, you might remember this, we're going to draw a line at Y equals 3. That's where our right triangle needs to intersect the line. Okay? Now, for this to be a right triangle, we know that either AB, wherever point A is, and wherever point A is, it's going to have to make a right angle, right, with either B or C. So it's got to be perpendicular. Either AC's got to be perpendicular to BC, or BC has to be perpendicular to BC. Okay? And I think we can handle this problem. So what we're going to do is this. We're going to draw BC, and we're going to find the slope of this guy. And we'll do it the easy way. We'll just count it. So we go down 1, 2, 3, and we go over 2. So the slope of BC is 3 over 2. Okay? That's our slope. Oh, -3 over 2, right? Because we're going down. Now, so that means the slope of either AB or AC is going to be, let's do AB, all right? So we're going to find A. It's going to have a slope of negative reciprocal, 2/3, right? That's what we need to have. So this is all you got to do. You just got to start at B and count the slope of 2/3. So we go up 2 over 3, so up 2, 1, 2, and then over 1, 2, 3, and then up 2, 1, 2, and then over 1, 2, 3. And sure enough, this point is on where Y equals 3, and it's perpendicular to BC. All right, so this point right here is 3, 3, so we could say that A is at 3, 3, so X equals 3. Dope. Now, there are two answers to these problems. You could have done the same thing from C and got an alternative answer. All right, do I want to take the time to do that? No, but I challenge you to try it yourself. I challenge you to try that yourself. All right, so all you have to do is find the slope of BC, just to review. Draw your line where it's going to intersect. So at this point, it was Y equals 3, because that's the Y coordinate. And then just count. Count the perpendicular slope. So this was -3 over 2. We just went up 2 over 3 now, up 2 over 3. And we have a perpendicular line. This must be a right triangle. And the brief explanation is ABC is a right triangle because BC is perpendicular AB, forming a right angle. All right, and then we got this one. This is a weird problem, but it's actually pretty easy. It says AB is going to go into DF, and ABC, D and F are collinear. Collinear, I don't think we might have covered this, but maybe not. Collinear just means on the same line. On the same line. That's what collinear means. And if you look, A, C, D, and F are in fact on the same line. Let D prime, E prime, F prime be the image of triangle DEF after a translation along line L, such that point D is mapped onto point A. Determine the location of point F. Explain your answer. This is a pretty ridiculous question, in my opinion. If D were to slide, do a translation all the way up to A, right? This is where, now that would push F all the way up to C. I think that's kind of obvious too. Maybe people don't see that, but that's just where it goes. So then your whole triangle just slides up like this. This is a translation from D to A. All right? So the answer is F prime is at C. So point F prime is at point C. Now my explanation is this. I know F prime is at point C because a translation is a rigid motion and rigid motions preserve side lengths. All right, so that's just saying that since DF is congruent to AC, if I were to move D to A, that means F would have to move on to A because this stays the same size. All right, nothing crazy there. And then the second part of this, I also still think it's easy. Let's move out a little bit. Let D double prime, E double prime, F double prime be the image of D prime, E prime, F prime after a reflection over line L. Suppose that E double prime is located at B. Oh, okay, is DEF congruent to triangle ABC? Explain your answer. Okay, so all we need to say is this. Hold on, I need to erase a little. Let's get a little eraser going. Okay, so let's get this out there for a second. All right, I can't. Sometimes it doesn't release. So if I reflect D prime, E prime, F prime over this line right over here, it would land directly onto this, right? Now, how do I know they're congruent? Well, D is mapped onto A, F is mapped onto C, and now it tells me that E is mapped onto B. So all the points have been mapped onto each other, and that's all you have to say. So triangle DEF is congruent to triangle ABC because all points are mapped onto each other. And I'd be specific because I think that's the best way to do this. Point D double prime maps onto A. Point E double prime maps onto B, and point F double prime maps onto C. All right, and since we know all the points correspond with each other, that must be a congruent triangle. All right, that's it for part 3. You can watch the next video for part 4.